A warm welcome to all. Myself Devika Dileep, and the topic today I am going to deal with is ozone depletion and Montreal Protocol. Ozone depletion is a serious threat to the existence and survival of human race. It has become a global problem for the present day. In the atmosphere around Earth, at about 16 to 60 kilometers above Earth's surface, ozone gas forms a layer around the Earth. The outer covering of atmosphere protecting Earth from ultraviolet rays of the sun is called ozone layer. In the other words, the amount of ozone accumulated in the upper atmosphere is called the ozone layer. This ozone layer protects all inhabitants and vegetation on Earth from the dangerous ultraviolet solar radiation, which are powerful enough to damage living cells apart from causing sunburns and skin diseases like skin cancer. Ozone gas is produced by the union of atomic oxygen formed by the splitting of molecular oxygen by sunlight with the molecules of oxygen. Ozone depletion means gradual thinning of Earth's ozone layer in the upper atmosphere caused by the release of chemical compounds containing gaseous chlorine or bromine from industry and other human activities. The thinning is most pronounced in the polar regions, especially over Antarctica. Ozone depletion is a major environmental problem because it increases the amount of ultraviolet radiation that reaches Earth's surface, which increases the rate of skin cancer, eye cataracts, and genetic and immune damage. The Montreal Protocol, ratified in 1987, was the first of several comprehensive international agreements enacted to hold the production and use of ozone depleting chemicals. As a result of continuous international cooperation on this issue, the ozone layer is expected to recover over time. Let's have a look into what is ozone depletion. The ozone layer is a region in the Earth's atmosphere that contains high concentration of ozone and protects the Earth from the harmful ultraviolet radiations of the Earth. The ozone layer depletion is the gradual thinning of the Earth's ozone layer in the upper atmosphere caused due to the release of chemical compounds containing gaseous bromine or chloride from industries or other human activities. Ozone depleting substances are the substances such as chlorofluorocarbons, halogens, carbon tetrachloride, hydrofluorocarbons, etc., that is responsible for the depletion of ozone layer. In 1973, the chemists Frank Sherwood Rowland and Mario Molina, who were then at the University of California, began studying the impact of CFCs in the Earth's atmosphere. They discovered that CFC molecules were stable enough to remain in the atmosphere until they got into the middle of the stratosphere, where they would finally be broken by ultraviolet radiation, releasing a chlorine atom. Rowland and Molina then proposed that these chlorine atoms might be expected to cause the breakdown of large amount of ozone in the stratosphere. Their argument was based upon an analogy to contemporary work by Paul J. Crutzen and Harold Johnson, which had shown that nitric oxide could catalyze the destruction of ozone. Then, in 1985, British Antarctic Survey scientists Joey Farman and Brian Gardner and John Shacklin published results of abnormally low ozone concentrations above Hailey near the South Pole. They speculated that this was connected to increased levels of CFCs in the atmosphere. It took several other attempts to establish that Antarctic losses are real and significant, especially after NASA has ratified matching data from its satellite recordings. The impact of these studies, the metaphor ozone hole and the colorful vision represented in the time-lapse animation proved shocking enough for the negotiators in Montreal, Canada to take the issue seriously. Also, in 1985, 20 nations, including the major CFC producers signed the Vienna Convention, which established a framework for negotiating international regulations on ozone depleting substances. After the discovery of the ozone hole by Take 2, it only took 18 months to reach binding agreement in Montreal, Canada. A tremendous effort by the international community culminated in an international agreement and the Montreal Protocol on substances that the depletion the ozone layer was ratified. Soon the plan began to take place. So let's see what are the effects can made by the ozone depletion on human beings. So if the ozone layer gets depleted, more UV rays enters the atmosphere. When these UV rays come in contact with the human skin, it can cause malignant skin cancers. It can also cause cataracts in our body. Vitamin D is synthesized when it reacts with UV rays. Excess D can also raise blood calcium level, increase mortality rates, etc. The effect is made on human on animals. High UV rays have shown that there has been epithelial damage in whales due to the thinning of the ozone layer. More sun damage has been notified in many aquatic animals due to ozone layer depletion and the effects made on plants. Increased UV rays can affect plants' life by damaging them under extreme exposure of UV rays. Plants' growth will be affected as well. The Montreal Protocol. The Montreal Protocol, finalized in 1987, is a global agreement to protect stratospheric ozone layer by phasing out the production and consumption of ozone depleting substances. The Montreal Protocol has proven to be innovative and successful and is the first treaty to achieve universal ratification by all countries in the world. Leveraging this worldwide participation, the Montreal Protocol has signed support global investment in alternative technologies developed by US companies and placed the ozone layer which was peril on the path of repair. In 1970s and 80s, the international community became increasingly concerned about the ODS would harm concerned that the ODS would harm the ozone layer. In 1985, the Vienna Convention for the Protection of Ozone Layer (exist EPA) formalized international cooperation in this issue. This cooperation resulted in the signing of the Montreal Protocol on substances that depletion the ozone layer (exist EPA) in 1987. Montreal Protocol, formally the Montreal Protocol on substances that depletion the ozone layer, an international treaty adopted in Montreal on September 16, 1987, that aimed to regulate the production and use of chemicals that contribute to the depletion of Earth's ozone layer. Initially, signed by 46 countries, the treaty now has nearly 200 signatories. So, according to the words of President Ronald Reagan, Montreal Protocol is a model of cooperation. It is a product of the recognition and international consciousness that ozone depletion is a global problem, both in terms of its causes and its effects. The protocol is a result of an extraordinary process of scientific study, negotiations among the representatives of the business and environmental communities, and international diplomacy. It is a monumental achievement. After the Montreal Protocol was signed, new data showed worse than expected damage to the ozone layer. In 1992, the Partnership Protocol decided to alter the terms of the 1987 agreement to end production of halogens by 1994 and CFCs by 1996 in developed countries. Because of measures taken under the Montreal Protocol, emissions of ODS are falling and the ozone layer is expected to be fully healed near the middle of 21st century. The importance of Montreal Protocol. The 1987 Montreal Protocol on Substances that deplete the ozone layer is a landmark agreement that successfully reduced the global production, consumption, and emission of ozone depleting substances. The ozone depleting substances are also greenhouse gases that contribute to the radioactive forcing of climatic changes. Using historical ozone depleting substances emissions and scenarios of potential emissions, the ODS contribution to radiative forcing most likely would have been much larger in the ODS linked to stratospheric ozone depletion had not been recognized in 1974, followed by a series of regulations. The climate change already achieved by the Montreal Protocol alone is far larger than the reduction target of the first commitment period of the Kyoto Protocol. Additional climatic benefits that are significant compared with the Kyoto Protocol reduction target would be achieved by actions under the Montreal Protocol by managing the emissions and substitute fluorocarbon gases and or implementing alternative gases with lower global potentials. The Montreal Protocol phases down the consumption and production of the different ODS in a stepwise manner with the different timetables for developed and developing countries. Under this treaty, all parties have specific responsibilities related to the phase out of the different groups of ODS, control of ODS trade, annual reporting of data, national licensing system to control ODS imports and exports, and other matters. The developing and developed countries have equal but differentiated responsibilities. Most importantly, both groups of countries have binding, time targeted, and measurable commitments. The treaty evolves over time in light of new scientific, technical, and economic developments, and it continues to be amended and adjusted. The meeting of the parties of the governors body for the treaty, with technical support provided by the open-ended working group, both of which meet on an annual basis. The parties are assigned by the Ozone Secretariat, which is based at UN Environment Program headquarters in Nairobi, Kenya. What can we learn from Montreal Protocol? Sectoral approach could be applied to climatic change. Take two high emitting industries, cement and steel in manufacturing. A coordinated effort that dives the climate problem into sectors can encourage faster learning. And like industries adjusting to the regulations of the Montreal Protocol, this sectoral approach can drive technology forward while reducing environment impacts. The Montreal Protocol also called for multilateral fund established in 1990s, which was basically money contributed by development countries and renewed periodically that period, developing countries and developing country industries to make the switches to the new green generations of chemicals. A similar pledge exists in the Paris Agreement called Green Climate Fund, which pledges 100 billion dollars annually by 2020. So far, however, donor nations have only contributed 10.3 billion dollars, according to the Los Angeles Times. Another big reason the Montreal Protocol worked was because of the public support generated by scientists turned advocates. The advocacy must be present today if we are going to reduce some of the most devastating effects of global warming. Climate change is also inherently tied to the economy. Greenhouse gases like CO2 are prevalent in huge sectors of national economies like transportation, manufacturing, energy, and infrastructure. Comparatively, CFCs and other ozone depleting substances were limited to few industries. The ozone problem was confined to a limited number of chemicals and a limited number of companies. Not as in the case with climate change, a transformation of the global economy away from 2 centuries of development based on fossil fuels. The limited scope of CFCs and the ozone hole also helped focus the efforts of scientists, making the problem much more manageable to solve. allow the scientists, technologists and policymakers to learn faster, the technology to develop faster, and for scientists, business and policymakers to gain confidence to do more and more. The focus across sectors may be where we can start looking to the Montreal Protocol as a model for our approach to tackling climate change. Roland and Mariana became advocates, which made them prey to backlash and skepticism in the short run. But at the same time, it got the point across and delivered the urgent message of the ozone hole and rewarded them a Nobel Prize years later. Because of their advocacy, says Salke, people began boycotting bug sprays, hair sprays, and other spray that can propel these ozone depleting chemicals into the atmosphere. Advocacy is understandably a big leap for many scientists who prefer the lab to the press room. But when it comes to an issue as important as climate change, it's necessary. One can already see the changes in scientists representing the Intergovernmental Panel on Climate Change acting more and more like advocates with each new terrifying report. To drive this message home, scientists need to become powerful communicators using clear, accessible language, real life examples, and relatable metrics. Another lesson from Montreal to solve a runaway environmental crisis, it helps to bring it in check quickly. The Montreal Protocol worked because an international committee assembled and solved the issue with the urgency the crisis demanded. They recognized that every day they didn't address CFCs made the problem worse. Point in case 2018's landmark IPCC report, which gave us 12 years to avoid catastrophe, wouldn't have been so drastic if we had started making gradual changes back in the 80s. This precautionary principle is important because it avoids far bigger, longer, and expensive and potentially more damaging consequences that can arise by postponing action. Even eventually, with the superb cooperative effort of governments, the UN, industry, and NGOs, it can take decades to turn around a big global environmental challenge. As we know, the ozone layer will not fully heal for many years to come. Because of decades of inaction, we will also be feeling the climate effects of climatic change for some time. So, what happened from Montreal to Paris? Despite the scientific consciousness that humans have accelerated climate change, global leaders still drag their feet on the issue. For at least 30 years, politicians, scientists, and industries have recognized the cause of climate change and its catastrophic impacts. For one, in addition to the environmental impacts like harming plants and marine ecosystems, a hole in the ozone layer had immediate human health impacts. According to the EPA, a thinned ozone layer could lead to skin cancers and cataracts. People tend to react to that kind of threat, whereas climate change hurt us in the long run, but not always immediately. We are very well adapted to respond to immediate threats, but slow to accommodate moving challenges. Writes Josh Marshall in his book, Don't Even Think About It, Why Our Brain Are Wired to Ignore Climatic Change. A big part of Montreal Protocol's success is that it wasn't a one and done back in the 80s. Rather, the TT has been amended over and over, each time making the agreement better for the environment. The Kigali Amendment is the latest such update and it proposes to phase out HFCs starting with the higher income countries and working down towards all countries by 2024. This phase out would limit global warming by zero point 0.5 degrees Celsius this century. We need all hands on deck to slow and reverse the trends of global warming. The Montreal Protocol provides us with the good model of the future, showing a successful execution of international environment policy. Sure, the Montreal Protocol differs from Paris Agreement, but we can only stand to gain from studying the former success. There is still time to reach a manageable and sustainable future, but to do that, we must pull out all the stops. This includes learning from the past also. Hope all you have got an idea about ozone depletion and Montreal Protocol. Thank you. Have a nice day.